Well, I slept on it. I thought about it. I left it a couple of days. I've come back in, and I'm just not happy with the transformer mounting solution for the very, very heavy mains transformer. So what I've decided to do is add or draw up a basic design for a mounting plate for it. And I'm going to have two of these, one either side of the chassis. They're going to be 2mm thick, which is 80 thou. So we're going to be adding 4mm of support all the way around the transformer hole. So 160 thou extra thickness in total. So that's what we're going to do. So I've measured up the hole, which is here, and I've drawn out a design. So this is the internal size is the same size as the cutout in the chassis, and we're going to have just a mounting plate like this with M6 holes, which is 240 thou, top of my head, 6mm, something like that. 200 thou radiused corners, that's the internal radius, and that's what it's going to look like. So I'm going to go and speak to my machine shop and going to have those made up. So I printed another one off, cut it out, and as you can see, if I bring you in, that's a 1:1 ratio. That's how it's going to fit, like that. And I think that's going to be great. So as I said, we'll have one on the outside that the transformer will sit on, and then one on the inside as well. So we're sandwiching the original chassis in between two of these plates. I think that's the way to go. I really think that's the way to go. Just for no other reason than it will just put this issue to bed and I can move forward. Because as I said, even though it's my amp, you know, it annoyed me enough at home thinking about it that, yeah, I need to do something. And I think this is the best solution. So I'm going to get those made up. If I had a 3D printer, I could, which I am going to get at some point, I could mock one up and see how that goes. But I don't need to. It's just a simple mounting ring, isn't it, really, to be honest? So, yeah, I'm going to get these designs over to machine shop, get two of these made up in steel, and that should be all. That's all we really need, to be honest, I think. Yeah, so that's the solution. And what I might do is before we actually mount the transformer, I will install them into the chassis just to kind of compress the chassis and then make sure that everything moves into the right position relative to the mounting plates. So yeah, that's what we're going to do. I think that's the best solution, and it's nice and elegant. It's going to look good. It's going to add the support I want without taking too much weight. And to be honest with you, from the outside, it should be, you know, moderately invisible. We'll call it translucent. Okay. So it won't be immediately obvious from the outside that it's got these extra plates in place, but we know they're there. We know they're adding the extra support. So the issue, and I've mentioned this before, is that this is, I can't find another example of a transformer from Fender, at least, that weighs as much as this one does. It's huge. It's I think it's the biggest one they did. I might be wrong, but at least for this style chassis and mounting. So this is 16 gauge? Yeah, it's 16 gauge. And really, for something this heavy, it needs to be 14 gauge as a minimum. So in steel, not in alley. So yeah, I'm just going to weigh this transformer and just give you a comparison to other transformers. You kind of get an idea of just how heavy and beastie it is. Right, so I'll just give you a comparison really on these transformers, so you kind of get an idea of what they weigh. Now, all of these units and their equivalent weights designed to, you know, hang off the same thickness steel the same gauge steel that Fender used across all of those amplifiers in the black and silver era, actually in the brown era as well. So we'll start with, this is a 125 P1B, although this is a grand stack version. So this is for like a Princeton Reverb style amplifier. Just zero that. There you go. So it weighs just over 2 kilograms, 2.2 kilograms, which will be times by 2.2. Actually, can I do it on here? Can I just convert? There you go. 4 pounds 13 ounces. Give you an idea of the weight on that one. This is a 40 watt transformer for a Fender style amplifier, so like a Vibrolux Reverb, something along those lines. Just over 3 kilos. Nearly 7 pounds, that one. This is a 50 watt transformer. Weighs 4.5 kilos or 10 pounds. Okay, and all of these designed to hang off that same size transformer. And finally, the ultralinear transformer from the basement, the heaviest one. 6.9, almost 7 kilograms, which is 15.4 pounds. So absolutely ridiculous that, you know, Fender thought that that weight of transformer would be okay on a chassis that would also hold that. Do you see what I mean? It's just stupid, absolutely stupid. So yeah, that's why I think a lot of these chassis ended up being bent, because the steel is just not thick enough to support transformers of that kind of weight, especially if they get dropped and you get that sudden stop, but the inertia of the transformer keeps going and then obviously bends the chassis. So yeah, you can see it's just crazy, just absolutely crazy. So yeah, we're going to go ahead with those brackets. Now, I spoke to the my fabricator, my machine shop, and he said we can either do it in 2mm steel, or we can do them in 4mm alley, which should give us the same strength. And the alley is actually slightly cheaper. So I haven't decided yet. I'm going to have a think about that. But anyway, let's crack on. Okay, so whilst we wait for the transformer brackets to make, the temptation would be to not move forward with this build, because my next step usually at that point would be to start wiring in the output valve sockets and do transformer connections and all those things. Let me just show you over there. Do all this stuff. But I do want to make some progress. So I'm just thinking, is there any reason why I couldn't at least make some basic start, temporary start on some wiring at this end of the chassis? And no, I don't think there is. I'm going to run shielded wires from my grids, of course, on V1 and V2. But looking at my layout diagram, what do I need to do? Well, I've got some connections to make over the board and under the board. But no, I think I can at least start to make the connections I want. But what I do want to do is I want to swap out these carbon films for metal films, just to see if we can reduce noise in this amp any further. I was tempted just to build it with those and then swap them in after the fact. In fact, do I do that? Yes, because it'd be nice to measure the difference, wouldn't it? I'd like to get a known measured difference between the two. So actually, yeah, we're going to leave those in for the time being. And then once this thing is up and built, I've then got a baseline that I can use.
to see how much brand new components on a brand new board, and just switching the construction type makes a difference, if at all. We're always told that these things are, but until you actually test it for yourself and gather that your own data, you never truly know. Okay, so I need to pull the board out, make some underboard connections for... actually, are there any underboard connections? Are there any underboard connections? So I'm going to have to do an underboard connection for my grounds, because I'm going to do a preamp. I'm going to do a preamp ground up here. So I'm going to have to do an underboard connection for the two cathodes there. Is there a reason why I need to ground that anywhere else? Is there a reason I need to ground that anywhere else? No, I don't think there is. Sorry, I'm just looking at the redrawn layout diagram here. So rather than using all the different grounding points along the brass strip, I'm going to ground everything on a rail, or ground everything to a rail and then up to the input jacks up here. I think that's the way I want to do it. So the only other connections are this jumper from this point here over to here, which they've got a black wire there, so I need to find that original black wire and reinstall that. Now they've got it going over the board, and I think that's the way I'm going to keep it. The only wires I want underneath the board are grounds, if at all. But yeah, I am going to join this grounding point over to this grounding point here, so that will be an underboard connection. And over here I've got a slightly different design, because remember, I'm not using the original bias circuit, so the phase inverter grounds up here to the brass strip. Now, do I want that grounding? I need to find out where the phase inverter supply is and ground it to the same point. So I'll work that one out. But yeah, I'm going to pull the board and at least start with some of this. So I was just looking for it on my original diagram. You can see it's twisted in with this signal wire as well, so a black and white twist, which is still on the original board, which I'm trying not to touch with my finger. So let's get that wire off. Right, get that out of the way. Don't touch it, don't touch it. Right. Just give this a quick wipe down. Maybe get some IPA on it too. Good old baby wipes, eh? Okay. So we are now looking then at which way do you twist? Was it that way? Is it that way? To the top of that there, so they're going there. Okay, yeah, this is going to work. This is going to work. So we want white up here. black here. Then over this way, black is going to this point and white is going to here. Yes. We neaten that up somewhat. Like that. Look at that. Cool. Right, what else do we need? Oh, we need that ground. So it's this one here, which is going to connect to this point here. Who's nipped my black? Who's nipped my black? Black wire, where are you? Brand new roll, look. Okay, can you see what's going on? You see what I'm doing? You can come over a bit there to there. Brand new roll of black. Good job. Right, so that's that overboard done. Are there any others that need to be done before the board goes in? Well, looking at this, there's none on this side. But there is over here. So you've got the two wires going to the grids, the red wire from that one. And that's hooked over. So this is saying that's fed from the red wire, which was correct, and the other grids are fed from another red wire. So it's two red wires we're looking for. Ah, there it is. So you've got this one here and this one here. Do I want to do it that way? Or, as I'm now doing it differently, do I put a hole in the board there and have them coming from underneath out the top? Yeah, I think I'm going to do it that way. So I'm going to want to drill a 6mm hole roughly here for my grid wires. One moment. Right, so that hole is drilled. Now this is the original red wire that I've cleaned up. See how dirty it was? For these two sockets that connects this point here to this socket, and it's daisy chained over. And that is still going to be long enough, because what I plan to do is come out from the hole with a twisted pair down and along and into there, and then I need another one that's going to come over to here. Now the other wire that came from here originally, if you look on the diagram, it's this one here, and it kind of scoots along there. It's not long enough the way I want to do it, so I can't use it. Now what is this orange wire, which was used in the preamp section, connecting the output of the tone pot underneath the board to the grid of V1B. Now I'm not going to use it because I'm going to use shielded wire there. Unfortunately, it's not long enough, so I was going to try and get away with that. So what I'm going to do is we'll have to use some new brown wire. So I've got brown and red on the right, brown on the left, and then I can twist those in and get them exactly where I want them to go. So that's going to be my solution for that. We'll get this out of the way. trim those short, trim this one short, and we're going to go brown is, sorry, red is right, that's how I'm going to remember it, which is this one here. This one here. And brown, we'll just do an extra long piece just in case. So my twister's going that way. Something like that. Something like that. Offer it up again. So that's going to have no problem reaching my grid there, is it? And this brown one can come all the way along. Needs to be roughly that long. Cool! Happy with that. Really happy with that. So that's those. Get you back out the way. The rest is all overboard connections. Come over here. Everything else just connects in a normal place. The only thing is, what were these two white wires here, this white wire twist? So we go back to this diagram and say, well, white and white. Oh, that's the twisted pair from the bias pot, isn't it? Well, I'm going to do those over the top anyway. Well, no, it's just going to be a single one of mine, so I don't need to worry about that. Cool. Just checking, is there anything else I want to do? Negative feedback goes over the top. Yeah, that's easy enough. Easy enough. Just need to think about this ground. Phase inverters. We need the schematic, really, don't we? So the phase inverter here, that's the ground for it. It's fed from point C, which is this one here. So it's got the 222s, then our dropper network. Then we've got the 1K, then we've got point C. Does it show it on the... Does it call it point C up here? No, it doesn't. But it's going to be... Is R44 or R45 the 1K? R44. So that the filter cap between those two resistors, which is here, so it's C27. This is black wire here, which is also the ground for the bias supply. Okay. Which is, we work this one out, black and white come through those holes. Okay. I think it's the preamp ground. I think the phase inverter will ground at the preamp rather than at the power amp ground. Let me just double check myself. So the schematic says, we'll go through it again, phase inverter ground powered by point C, a filter node C, which is the second to last one. Here, on our layout diagram, it's C27, which grounds to the same point as the so through the two holes you've got a grey and a white and a black and a white. So why can't I see that on here? This one here is a white and a grey, so it must then be. Am I missing one? Or is it just drawn in a weird way? No, it is that one. So it comes through this hole here. Black, yeah, there you go. There's also a green coming through it. So that black, they've run all the way up over to here. So the bias supply grounds. So where does this one ground? Where does point D ground? Which will be this one here, this light green wire. Comes through the same eyelet. Oh, they just labelled it as green and it grounds up here. So why did Fender separate those two grounds, even though this grounding strip is all the same? I'm going to ground it all at the same point, I think, over at the preamp side. If it turns out to be noisy, I can always ground it over at my power amp side. But I think I'm going to call it a preamp ground. It's that difficult choice, really, because there's, depending on your thought process and the methodology you want to use, you see, if it was C26, I would be tempted to do it there. But as it's past this lot of filtering, I'm going to do it there. That's what we're going to do. Okay. Which means, on the board, we're going to connect it to this point. Am I sure? What do I want to do? Decision made. Decision made. If it's wrong, I can always change it. So we want to ground that one to there. Sorry, that took ages. This is the problem with working things out live on camera. Is that I think about things out loud. So unfortunately, you guys get to hear my thought processes. I can always change it in the future. Always change it in the future. I'll come in tomorrow and I'll have thought about this overnight and said, actually, no, I'm going to do it the other way. Right. Okay. Right. Is that all I need to do? Everything else can be done over the top, can't it? Yeah. Right, I'm doing it. I'm going for it. I've made a decision. No. Okay, okay. Right, let's get wiring, shall we? So I need to add my heater links in between pins 4 and 5 on both of those sockets, easy enough, and I need to do a jumper between pins 8 and 8 for the shared cathodes. Easy enough. All right, we're going to time lapse this bit. Enjoy. Right, okay, so V1 and V2 all wired in now. I could do the phase inverter, but I want to have a bit more of a think about it for the time being. I don't want to go too far ahead with it and then realise I've missed something off, or I should have done something in a different order or whatever. But that's V1 and V2 all wired in now, and it's just the 4 grids that are going to have the shielded wires coming from the inputs and the master volumes. Sorry, the volumes on each channel. The master volume control also has shielded wire going to its dedicated places. So that's probably going to be, those 5 wires will be the last things that I wire up, to be honest. So yeah, that's some progress on this amp. I've managed to reuse as much of the original wire as possible in its original location. So this wire here, for example, was that original grid wire, plate anode wire on the old board. So remove the wire, clean it up again, install it. All of these are the same. The only one that I couldn't find was, I think it was yeah, this one here, and the jumper between the two. I couldn't find the original one. So, but I've got so much of this wire in stock, it's fine. If I can't use the original stuff, I've got, you know, vintage replacements, which is fine, which is great. So that's coming on nicely now. The best thing is, if I have made a mistake, because I haven't wired up the top side of the board, I can just remove the mounts and just fold it forward if I do need to do anything on the underside. So yeah, that's good news. Happy with that. And yeah, going to keep cracking on with building it, really. Thanks for watching.